Hi guys, so in this video we're going to look at what's called differentiation from first principles. You saw in the last video where this expression came from, so the change in y with respect to the change in x was given by the limit of h heading towards 0 of f of x plus h minus f of x over h. And what we're going to do is we're going to use this idea in order to work out the differentiation or the slopes. Remember, differentiation is the slopes at any particular point on a function. So what we've got here is it's set into 4 distinct stages, and if you do this every single time, then you won't get it wrong. You have to keep this notation going, guys. You can see here how I've set this out with the f of x plus h, and so on and so forth here. If you miss some of this out, then you won't pick up full marks. Okay, so the function we're going to look at here is f of x maps onto 5 minus 3x, and we're going to ask to differentiate this function with respect to x from first principles. So the first thing we do is we write down what f of x is. So f of x here is equal to 5 minus 3x. The next thing we do is we put x plus h through this original function, which is here. So wherever I see an x here in this function, I'm going to replace it with x plus h. So you can see here what I'm going to end up with now is 5 minus 3, and wherever I see that x, so this x here, now becomes equal to x plus h. So just put a bracket, x plus h. And we'll multiply that out because we're going to need it later. So 5 minus 3x minus 3h. Okay, the next stage that we have to do here is f of x plus h minus f of x. So let's do that. Here's my f of x plus h. Here's my f of x, so let's put them in. Don't forget to use brackets, boys. So I end up now with 5 minus 3x minus 3h, okay, minus f of x, which is 5 minus 3x. And what we're going to do then is just tidy that up. So you can see here, we're going to get 5 minus 5 from here, so they're going to cancel. Get minus 3x here, minus 3x is positive 3x. So all we're left with now, guys, is minus 3h. So hopefully you can see that there will go to minus 3h. Okay, so once we simplify that out, just to show you again, 5, take away 5, minus 3x minus 3x is positive 3x. So all we're left with now is minus 3h. Okay, so we've done this bit. Now we're going to divide by h. So this is equal to minus 3h divided by h. And you can see here that the h's will factor out, so that there will leave us 1 and 1. So we now know that that is equal to minus 3. And what we do now is we do the last bit where it says we take the limit of that. Now all we're doing is, you can see here, this is f of x plus h minus f of x over h. So we're just going to take the limit as h heads towards 0 of this. So let's just write that down. So this is equal to, I'll just start again, equal to the lim as h heads towards 0 of minus 3. There's no h's in this, so the answer to this is just 3. So when we get this, we get is equal to minus 3, and then we say that becomes dy dx is equal to minus 3. We can also call it m if you wish, because at the end of the day it's the gradient. Remember, it's the rate of change. Now what does this mean? This means that our slope at any point of this function is equal to minus 3. And if you think about it, that would make absolutely perfect sense, because this is a straight line. It's a linear line, 5 minus 3x, and we know that this is going to be minus 3. We know what the grade is going to be, because if we have this other form, y is equal to 5 minus 3x, that's what it is. We've got y is equal to 5 minus 3x. You just quickly rearrange it. Y is equal to minus 3x plus 5. Remember, because of the fact we know y is equal to mx plus c, our m will be our slope, and we've proven here the slope is going to be equal to negative 3. Now, of course, this isn't always going to happen where we don't have any h's left when we take limits, and in the next example, I'll show you what happens when there are h's in our function when we started to do it. Okay, so here we have the quadratic function, and it's given by 2x squared minus 3x plus 5. And we've got to differentiate f with respect to x from first principles again. I'm just going to write down what it is, just in case you can't remember. So remember, dy dx is equal to the lim as h heads towards 0 of f of x plus h minus f of x all over h. Okay, so when you use that again, then what we've been asked to do is give an interpretation of the derivative in terms of the curve and find the instantaneous rate of change of f at x equals 2. And this is just another way of saying it. F dash is the same as dy dx. I'll come back to that in a second. So, first thing we need to do is work out f of x, or go through the stages. So what we have is f of x. And f of x is equal to 2x squared minus 3x plus 5. Not a bother. Next thing we need to do is work out f of x plus h. And that's equal to, well, wherever we see an x, in this original function, we're going to replace it with x plus h. Okay, not a bother. So 2x plus h all squared minus 3x plus h plus 5. And we're going to tidy that up as much as we can. So we're going to get this bracket out. So 2x squared plus 2xh plus h squared minus 3x minus 3h plus 5, and just multiply everything by 2 in this first bracket. We get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. So my f of x plus h here is equal to this expression on the right hand side. So there's a fair bit of work there. We've multiplied out this bracket, we've multiplied this, we've collected everything together. Okay, so there's a little bit more work than the first example. The next thing we have to do is work out the f of x plus h minus f of x. We'll do that next. So f of x plus h minus the f of x, and that's equal to, well, it's just this big long expression here. Take away this one. So let's write it in. So what we have is 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5 minus, and don't forget to use your bracket, 2x squared minus 3x plus 5, which is the f of x here. Now, if you've done this properly, guys, what will happen is that all of these will cancel out with something in here. So hopefully you can see that this 2x squared will go with this minus 2x squared here. Okay, this minus 3x here will go with the minus 3x there. So let's quickly do that. And the last one is, you can see that this plus 5 here will go with this minus plus 5 here. So plus 5 minus 5, so they will cancel out. Now lads, this will always happen. Okay, so this will always happen. So that means that we are now left with is equal to 4xh plus 2h squared minus 3h. Okay, so my f of x plus h minus my f of x here collapses down after we've managed to just sort all this out up here. Once we've got rid of stuff, it comes out to be 4xh plus 2h squared minus 3h. Next thing we need to do is the f of x plus h minus f of x all over h. So all we're doing now, the next stage, is finishing this off. We need to put whatever the original, the previous thing was, we need to divide everything by h if we can. So let's have a look. That's equal to 4xh plus 2h squared minus 3h all over h. Notice that everything has h in it. So we're going to simplify and we're going to divide everything by h. So if I divide everything by h, then obviously that's going to go to 1. That's going to go to 1. That's going to go to 1. And that there is just going to go to h, because h squared divided by h gives me h. So let's just rewrite that and just tidy it up. That's equal to 4x plus 2h minus 3. So that's what we have now as the answer of f of x plus h minus f of x all over h. And this is now where we've got to take the limit. So notice we have h's in this one, unlike the previous one. So the last thing we have to do is we need to take the lim as h heads towards 0 of f of x plus h minus f of x all over h, which is exactly the same as taking the lim as h heads towards 0 of this expression here, which is 4x plus 2h minus 3. Okay, that means if we're going to take a limit, all we do is wherever we see a h, we're going to replace it with 0. Let's do that. So that's equal to, taking the limit now, 4x plus 2 by 0 minus 3. So the answer to this is 4x minus 3. And we change this now to dy dx, which tells us the slope of the tangent at any point on our original function. Okay, so an interpretation of the derivative in terms of the curve, what we're saying is that if we stick in any x value to this, it will tell us the slope of the tangent at that particular point. So for example, the 2x squared looks something like this. Looks like this graph's going to look something, I don't know, something like this maybe, something like that. Okay, and what we're saying is that whatever point we take, like that or that, this dy dx function, what I like to call the slope function, will tell us the slope. Once we picked a point, it'll tell us the slope of the tangent at that particular point. So that's what the interpretation of the derivative is, or you can say it's the instantaneous rate of change at that point. Okay, so it says find the instantaneous rate of change of f at x equal to 2, i.e. find f dash 2. F dash of a function, so f dash x is exactly the same as dy dx. We can use them as and when we want to, and normally when we want to stick a value through a derivative, what we do, or a slope function, what we do is we use the f dash notation here. So what we're saying here is we want to stick 2 through our dy dx function. So all we do for that is we go back down here, and wherever we see an x in our dy dx, we replace it with what's in the bracket. Okay, and you can see here if we do that, we get 4 times 2 minus 3, which is 5. So let's just write that down. So f dash of 2, okay, is exactly the same. The other way we can write this is dy dx, and we can write x is equal to 2. So there's the 2 ways that we can actually write exactly the same thing. Okay, and that means that's equal to 4 by x, which is 2, minus 3. And if we work that out, that is going to be equal to 5, as I said before. What does that tell us? That tells us that the slope of the tangent when x is equal to 2 is equal to 5.